Hey folks, coming to you live from the kitchen sinkhole. Just a little project for you. This is the adjustable angle of the dangle slide from Hardinge Lathe cross slide. So let me try to explain for a moment how this all came together. So this would be our base plate. It rides. It's got a T-slot on the top for the tool. Well, base plate. Base plate for the tool. This is the top. The tool goes on. This is the bottom that goes on the cross slide. There's your dovetail. The gibs are out. It's right full of dirt and lots of interesting machine features, which if I'd been rolling the film while I was taking it apart, it would have made more sense. So this feller, get a little confused malated here. You know what? Herp-a-derp. There's a T-slot type contraption on the cross slide. This is the bottom. So there is our angulations. So bottom wise, this stiff washer, and then this paper thin, thinner than paper. This is paper thin. This is thinner than that, and then this is paper thin. There's a perfect shim stack here, which spaces this guy just about exactly right to ride around. Reason being, you can see the scorch marks from the dirt. This sits on top of it, and that shim stack helps slide to my jigs. Something about like that. Hold on. Let me just do this the easy hard way. So that goes there. This is just a whetstone for knife sharpening. I'll get into that in a minute. So pretend the shim stack was there. Hoop-a-da-boop. Drop the gear right out anyway because don't have a way to hold it in until I put the pin through it. So about like that. And this is a little finicky with the gib. It has to be done with the gib out. So the teeth my jigs go this way. I ain't got it lined up quite yet. Alright. So that gear tooth, there's a knob that I don't have attached. Actually, I don't even have the lever at all. But that lever would go in there and it would turn that gear and drive the slide forward and backwards, or whatever angle you had this set. So this is the assemblage approximately. A lot of little screws to hold it all together. The one shaft for the gear with the lever is one piece. 2.0 is the shaft that goes up through the center wise for the pivots. This is a screw. That's just this little hole here. And I think some of these others are just yeah. So this is an access hole to get to the head of a screw, and there's a screw that goes in there that pins that shaft from coming out. That's the lock. It locks the rotating parts to keep it from pivoting. And then there's a screw that goes in there, which that shaft goes through to our gear, so that would lock our forward and reverse on the slide. Now this has just been sprayed with WD-40. This guy has gone through his stage 1. I just used some gray Scotch-Brite. Is ultra fine or whatever. It's not as coarse as the red or the green. Green is the coarsest. Red is like industrial green, and not really that much coarse, not really that much finer, really just industrialized. And the gray is sort of a medium weight, and the white is like you're only going to scratch plastic with it. So I used the Scotch-Brite on the dirty parts so they're no longer rusty and blackened. And I should wipe this thing down so it's a little bit shinier. And then I switched to this used to be white, so now it's embedded with bits of aluminum. This is a whetstone, and you keep it good and oiled, and you make sure there's absolutely no fine grit, which I can feel on this guy right now. It's all oily with WD-40, and you stone the burrs. So you can see there's kind of a shininess to the edge, probably because I rounded them off a little bit, but there were sharp protrusions from either the disassembly or the wear and tear on this guy. And actually the numbers, man, they were real beat up, and this kind of flattened that down so that everything will move and slide. Everything will slide nice. Now I got one of these, and this is a fine, they call it the soft Arkansas, because I guess that's where they quarry the stones, and the soft is it's actually coarser. They call it soft, I guess, because of breaking strength. And the bigger grains must have a lower strength, so they call this soft. And then there's a hard Arkansas, which is like the finer than this. And then there's like a glossy or translucent. It's like a black glass, if you can believe it. It's that fine, and that's the hardest of all. And normally in polishing, you want to start with a heavy grit and go finer, and that's what I was doing on this, because this was not a high polish and had lots of big scratches. Now on my good ways and my high polish areas, you guys start with the hardest stone, because I want to do the least amount of damage and get the burrs off and stop. So just you know, oil it up, kind of move it around. There's plenty of videos on the technique. You know, some like it a little to the left. It's got a nice suction when it's well lubricated, like I'm lifting up on it right now. Pop. So, yeah, you just kind of, you want to move, and you want to give an even amount of rubbing to the whole surface area, but mostly I want to focus on breaking the burrs on the edges, maybe a little bit down the sides of this and across the top of that, and keep spraying it with WD and occasionally wiping it down so I can see what I've got left to do. But keep flowing the WD or some kind of oil. I like the WD because it's thin and it carries stuff away easily, but I use the pump sprayer to keep the grit and the dirt off the stone so I don't dig scratches into this, because if you get sand or metal flakes or something in there, a big piece, you'll do this and you'll see more streaks. So I kind of move in small circles, and I move around the edges so any streaks are hopefully getting wiped off the edge and then scraped off on the outside. And once I've kind of got confidence I'm flat, I go through the middle with no grit, spray everything down, flip it to the opposite side because I don't want this to wear unevenly and be dipped in one way or the other, and I do it again with the opposite side, same, flip, so on and so forth. So I'm going to do this next, scrub with the Scotch-Brite first. And one more life pro tip, this deal is not a refillable guide. Alright folks, I got a phone call, and of course the camera dropped the video so it could ring on me. And then like a Moran, while I was on the phone, I continued scrubbing away. So here we go. This is our angular compounding device for the lathe. So I think I kind of went over this, but I'll do a quick recap. This guy goes on the cross slide. This part goes on the slide. This nut, which may have to be pressed in. No, it just had to be hammered out. This nut secures it to the cross slide while sitting down in the T-slot, so it doesn't interfere really. That is mounted on, this is mounted on that, with the 0 degree mark right here. And these shims go in here because this guy holds our gear. And I guess that's, the shims go underneath because they're keeping the gear teeth off of this. Because the gap to the top is set by the gib dovetail, and that doesn't have a shim device. So we'll get to that in a second. Never mind, I got WD-40 everywhere. But that has to be pressed together. So, oh, I made a huge mistake. Alright, so save that for when I'm ready to put the shims back in and get everything assembled, since it has to be pressed together. There we go. Angular measurement about like that. So this would go on your cross slide, which is fixed perpendicular to the headstock, the spindle, your part, etc. Now this rotates at whatever angle you like. I've done wedged it on there. Must be what the shims are for. Unwedging it. Hey, that's clever. Okay, so the shims would keep this from dragging on the outside because the inner part is recessed. Alright, now I understand. Alright, the gib is, shoot, still out in the garage. I gotta clean it up next. This feller goes about like that. Yeah, so it has gear teeth. If I had the shaft for that is this fella. Your gear goes, see there's the shaft hole. Your gear goes in there, shaft goes plink. This guy goes up, up, and over. Slide onto the dovetail. You have to add the gib last. And I can't really slide it around because that gear is just clanking in the hole. But if the gib was on, this would be fixed nice and parallel. And when you turn the handle, which I don't have the handle, I've got the handle turner in the garage, but I'll have to make a handle for it. When you turn that, turns the gear moves the rack, slides it back and forth. So again, this guy sits parallel to, or the perpendicular to the spindle. This lets you go whatever angle you like. Then you can move forward and backwards at whatever angle it's set. Of course, perpendicular to the spindle, your cross slide, of course, also has a lever. So it always can move perpendicular, but it can also move any other angle, including straight forward. Any pieces I forgot about. There's a lock, which is a devious little device. It is not, in fact, a bolt, even though it looks like one from the outside. And maybe you can tell. Alright, look here. I got a step, and there's no step right there, but there is on the sides. I turn it 180 degrees, no step, step. So they did some eccentric turning, and I think it maybe this is the main or full diameter and this is a small diameter, and only this piece is turned eccentric. Eyeball lasers say that's about what it is. So turning this guy with a big old hex key eccentrics it, cams it out to the side, and it presses on. It goes in here. Again, I wedged it all together now like a moron. Well, the camera can't see as good as my eyes can to tell you. Okay, there's your gear. I'm not really sure how that works. There's a stop screw. One of these guys. Oh, you know what? I can get the laser light in there. It looks like it presses on the screw. And the screw, this is also hard to laser eyeball, but the counterbore for that screw is shallower than the other. So I think that screw, maybe it never really tightens up all the way. Has a little bit of wiggle room, and that cam bumps it up into, depending on which way it cams, it may bump into this thing and break. I think it breaks the angular rotation. This is just an access hole, so when the whole thing's assembled, you can take it apart from the bottom. Of course, I had to beat it halfway apart. See this plug? This plug goes through here from the bottom side and matches up with this slot to keep it. Even if you unlock it all the way, you can't slide it all the way off the end. Similarly, the gear shaft. No, not the gear shaft. Oh, that's our cam. Okay, yeah, our cam deal. That's how that works. Our cam deal bumps up on this guy through the center, which would have been right frozen up since this was binding to begin with. Bumps that up, and so it must either tighten up on this plate or tighten this plate to that plate. Probably what it does. It locks something. Everything was locked to begin with, so I couldn't really play with it. Never mind the fingerprints. Our shimmy, slightly thicker than a piece of paper one. The thickness of a piece of paper one. And the, holy crap, This is like some gold foil, half the thickness of a piece of paper shim. All three of them were stacked in here. Screwdrivers were just for disassembly, and the 2 Arkansas whetstones soaked in WD-40, which is solvent and a little bit of silicone oil. The soft Arkansas, which is medium to fine. It's pretty fine for grit rating. And then this would have been a finer hard Arkansas stone. There's others. These were just cheap and readily available. And I used those to take all the nicks and scratches off between all the fingerprints and the gloss. It's hard to tell, but these are real clean compared to what they were, and they don't have any sharp burrs like they used to. So everything should work pretty good when I put it back together. So I'll get you a picture of that shortly. You know, tomorrow, but it will be 2 seconds for you. Just to pause for a moment to tell you guys I weren't lying. I got this thing about halfway back together. The shims are inside the base. That pin is pressed in to hold the top to the base. And look at this. It turns so smooth I can do it with one thumb and no hands. Yeah, that's pretty nice. And I tried my darndest. Oh, it's draining on me. Tried my darndest to get that inner pin to line up. To get this fella to line up that way for my eccentric shaft, and it's, as you can tell, it's slathered with WD. What I like to do when I'm reassembling, especially intricate mechanical parts, they got to be clean and lots of moving and no friction, sliding stuff especially, is even though I've done all this cleaning work and I've set it up to dry, wiped it off, made sure it was pretty, before I put it back together I take the WD-40 and I rinse, flood each face, holding it so that it'll all run down to one corner and drain off. That way any grit is out of here when it goes back together. Now once it's mostly assembled, I will slather it up with some whey oil, spindle oil, whatever kind of machine, you know, air compressor oil, whatever is around the shop. I actually have spindle oil, and that's what this this device claims, mobile number 6 Volocite spindle oil. So I will drizzle it on there when it's mostly assembled or all the way assembled and just work it back and forth and get it in there. Right now it's soaked in WD-40, which is a solvent with silicone oil in it, I think. So not great for lubrication, great for keeping it from rust, for cleaning, you know, storage. And then I'll lubricate it good when it's back together, and I'll put it on the lathe. Probably. I got to take the turret off since I was test fitting that and did things backwards. I should have had the slide finished before I started the turret. Well, it doesn't matter. It doesn't got a motor right now. So yeah, let me go grab the other bit. Yeah, this produces a lot of EPA unfriendly trash. It's about a third of a kitchen trash can full of dirty rags and oil, so my house is going to blow right up. Alright, next part. I got to go get the gibs and the gib screws, give them a good wipe down, put them... I'll put the screws in. I won't put the gibs in until I get the slide in, and I got to get the shaft gear, eccentric shaft. This goes in the last because that locks it from coming off, and then the teeny screw. Look out for them office chairs. So you get a nice sharp plastic one got me today. You know, machining's totally safe, but that clipboard warrior will kill you. Seen this next bit coming from experience, of course. Get it halfway assembled, 3/4 of the way assembled, and whoop, doesn't go back the way I thought. Yeah, so this is the bottom side of the mill section and the top side of the bottom section. Unfortunately, we got 3 screws here and only 1 access hole. And even though these 2 little ones are the same size, they're different distance from the center. I guess they were trying to give adequate clearance to this larger one, so they shifted it rather than lining it up radial distance like that one. So even though the access hole could have worked for that screw, it doesn't. So this shaft and the gear have to go in first, and then that screw, and then this stud is holding it up. That stud goes into the slot up here for keeping this from sliding off the end. Better make sure that this doesn't need to go back on before that stud does. I'm about to find out the hard way. And then, problem numero dos, gotta, I guess the calibrated amount of rust being gone means that I no longer have the right distance for my little bitty shim washers. That's one right there, even though it's hard to tell. There's the edges of some of them. So when I put put it all together, I turn my cammed pin, which pulls this piece with a hole in it up, pulls that up. Unfortunately, it doesn't tighten up enough to stop this from spinning, so I don't know if adding the shims is going to make it better or worse. I guess if it's still loose, it needs to be thicker, and I took the dirt out, and that made it thinner. I may have to go cut me a piece of aluminum foil or something similar. Of course, I'm sure that's, well, I would have galvanic whatevers. I would have, and rust tells me that's probably steel. So that's inconvenient. Maybe a piece of oiled paper cut to a circle or thereabouts would do it. May have to get the micrometer out and measure different thicknesses and swap some of these in and out, but I'd rather just stick a piece of real thin paper on top of it and call it good. You know, I don't care if the cam is a little stiff and if I have to wear it in or something. So we'll try that. Yeah, I'll get it reassembled. Like I said, it'll be tomorrow. I got ahead of myself trying to do it tonight and can't think quite straight. But yeah, and I'll show you guys what the final product looks like.